So Stefan is his second year here, right?
In person, yes. So it's my third talk.
Yeah.
I was one I was
Online.
doing remotely.
Yeah.
That was during the COVID times.
And so last year we know Stefan is has a hobby of trying new beers. Yeah, last year we went and brought him Westfleteren. What was that? Blonde?
12.
It's also 12.
Yeah.
Oh, I thought it was different. So, okay, 2 years in a row he drinks here the Westfleteren 12%. So there are 2 other options. You know that, right?
Oh, yeah, I know.
Yes.
I know. I haven't tried them yet.
Okay, next year we'll do better.
Cool.
We'll bring the either blonde or I think it's 8%, right?
Mm-hmm.
Yeah. Okay,
Beautiful.
next year we'll do better. But for now, Stefan is going to tell about TypeScript, right? And you have a new book out?
Yes, that's right.
Okay.
I have a couple of copies with me. There will be a quiz.
Quiz.
Sometime.
Here,
talk.
and at this talk? Okay, I'm staying.
Yeah.
So give him a warm welcome with your applause.
Thank you very much. Thank you. The TypeScript completeness conundrum. First of all, I need to give you a warning. I guess I start all my talks here with a warning. This is a very personal talk. It is my third talk at what I call the NG Belgium TypeScript trilogy. And like any good trilogy, I started out with a call to adventure, showing amazing features that the type system is capable of doing in my first talk, TypeScript, gradual, structural, dynamic, and static. The middle part is usually that part where the heroes face their greatest fear and meet the story's ultimate adversary. And this was in the lies that we tell ourselves using TypeScript, where I showed code where the types lie to us, and where the reality that lies behind the types is frightening. So now on for the third part. This is Peter. He's a friend of mine and one of my podcasting colleagues for the German Working Draft Web Development podcast. Every quarter, Peter and I meet to discuss the latest TypeScript features. And one thing that we found out over the course of our talks every quarter is that TypeScript has peaked in some way. There aren't that many new type system features coming, and it's more that TypeScript improves on the existing features. But I didn't believe myself. So I used one of the best programming environments in the world, Excel, and did a quantitative analysis, checking if our impressions are true. I went through the release notes of TypeScript 5.0 until the most recent one, 5.7. This was the area of TypeScript where I thought, well, the type system is slowing down. And I categorized each feature. And this is potentially error-prone because I did it in one of my free nights, and it's also very, very subjective. And this is the result. The categories are EcmaScript, quality of life, ecosystem, editors, and type system. In the category EcmaScript, TypeScript implements new and upcoming EcmaScript features and adds new functionality to the types of the standard library. And in the last 8 releases, we got 8 entries in the release notes. Quality of life features are changes where TypeScript gets either more correct or things that were hard to do in the past are now much, much easier to do. And we have a staggering 45 entries. The ecosystem, somebody writes some weird Webpack stuff and loads some module that shouldn't be loaded, but hey, TypeScript needs to support it now. There were 6 entries like that in the last 8 releases. TypeScript is nothing without its editors. Anybody of you who is not using Visual Studio Code? Okay, just a couple. See, Visual Studio Code was developed alongside TypeScript, and lots of features in TypeScript are driven by editor use. So there have been 11 new features for editors, like new refactorings, new semantics on how your code could be written differently. And for the type system, 0. Not a single new addition to the type system. And this is kind of sad, because there are a couple of features that I'm missing when writing TypeScript. And TypeScript's goal is to make JavaScript somehow formalizable. And I'm a JavaScript developer, so I wrote a lot of JavaScript in the past, and there are a couple of things that I wish TypeScript would understand. And one of those things is mutability. TypeScript is, since its inception, extremely bad at recognizing mutability. And JavaScript developers are really good at mutating everything. So and usually you take an empty object, you slap a couple of keys on it, add some values, and you have a new shiny object that has your data. We can dynamically add new properties in JavaScript, and people use that. They create dictionaries doing that. Or like in that case, tell if a particular object has been visited. So I add this visited property to it and set it to true. But if I try to visit a certain array of objects, here it's an array of person, TypeScript tells me very loudly that what I tried to do is not possible, even though this is absolutely fine and valid JavaScript code. There is a way how I can hack myself to a solution by using assertion signatures and generics. So here I say that I assert TypeScript that the type is what I get in, plus a new property that is of type Boolean. Please ignore the asAny call here. This is a little hack that I had to do to add a new property, and I'm pretty sure we all have done that at some point in time. We all are guilty, and there's absolutely no shame in it. Any is totally fine. If I do that, TypeScript will correctly understand that after I do the visit call, person is actually person and this new type that I have created. So person.visited works as intended. One line later, get the same error. So 50% of a solution. What I think TypeScript would need would be a way to declare mutability. This is hypothetical code. This is what I made up yesterday night. Having a little keyword that is an indicator that things are A, allowed to change, and B, TypeScript can infer changes through this keyword. It would give us room to allow for those dynamic structures. Another example. This is a builder from a command line application. I'm allowed to add different options. Those options can either have required parameters, or they are Boolean flags, or maybe they are both. The command line builder is so flexible to do that. And when I call the little .opts command in the end, I get all past options in the JavaScript object back. That would be the idea. And this is surprisingly easy to type. I have a type with a generic T that starts with the empty object. Every option call locks the string that I entered to a type parameter u, and then the option call returns a new command with the type that was stored in command and the newly parsed u. As I said, surprisingly easy. What we basically do is we store all commands with every option call in the command type itself, and then it's available by calling .opts. The parse command, well, it's a type that is quite a mouthful. But what we do here is that we use string template literal types to infer the option name, which happens here. So here I just say, well, this is the option name extracted from the string. Then I check if this is a string that either has a required parameter, an optional parameter, or no parameter at all. And depending on what I find here, I infer the right type, which is either a string, a Boolean or string, or a Boolean with the inferred name as the key. And actually, this is the stuff that I like a lot about TypeScript, that you can model things like that. I think this is very impressive, and one of the things why I love working with TypeScript. And it works surprisingly well. If I use this type in my code, the moment I call .opts, I get a beautiful type back. It's episode of string, keep of Boolean, and ratio of string or Boolean. And this excites me about TypeScript, that it's possible to express your code in such a detailed way and offer well-typed APIs for whoever wants to use it. It's remarkable how well this works, except when it doesn't. So this here is a valid usage of the builder. I separate the calls of option in two separate lines, but the moment I call .opts, opts is the empty type, the empty object type. All type information is lost. And yes, I can cheat my way around it using assertion signatures, but if I have assertion signatures, I can't have a fluent interface. If I have a fluent interface, I can't have assertion signatures. It's either this or that, it can't be both. And the mutable keyword I introduced a few slides earlier can't express the interior mutability that this type needs. Maybe this is also a reason why the mutable keyword doesn't exist. Here, in this case, we are lost. And this is then VendorCam. Dan is the author of Effective TypeScript and contributes to the TypeScript project. I had the pleasure to review the second edition of his book, and what I found out is that Dan and I usually have contradicting advice when it comes to TypeScript. And this is great. I love Dan for that because it broadens my horizon. Dan has a different perspective, he has a different background, he works on different problems. If Dan sees something a different way than I do, there's usually a reason for that. And when I thought that TypeScript 5.5 was peak TypeScript, he called it a blockbuster release. So I got curious, why does Dan think this is a blockbuster release? Maybe I was in need for a little perspective change. So let's look at a couple of features that have come with 5.5, 5.6, 5.7 that fall into the quality of life category. Things that you could do before, but which are now nicer to use. And one thing is inferred type parameters, which has been written by Dan actually. I have here a function, make national bird call, that takes a country parameter and it gets a bird out of a map. Rightfully at the line const bird is nationalbirds.get. Birds is bird or undefined because it's not guaranteed that this particular value is available. And if I do if bird, TypeScript correctly knows that the undefined case is gone and the bird is of type bird. So this was something that you could always do. This is control flow analysis. This is great. If I have it in a function, because I have a filter operation here on an array, TypeScript still thinks this is birds or undefined, even though 2 lines later, I make sure that it can't be the undefined case. And with that, this line does not work because bird is possibly undefined. And this is something that Dan worked on. Dan worked on a way to infer a type predicate from a function call. So now, with TypeScript 5.5, TypeScript correctly understands that this filter call here actually filters out all undefined birds. So bird is now the birds array. This is a huge quality of life feature. And it works like that. Those are the inferred type predicates in the top lines, and then just below is the one that TypeScript thinks or infers from that. So I use an isBirdReal function that takes bird or undefined. If I make a bird not equals undefined case, TypeScript thinks that it can add the bird is bird type predicate to it. Same with his number. It takes an unknown value in, and TypeScript understands that x is now a number and adds the type predicate to it. Again, this is not something that I wasn't able to do before, but now TypeScript does it for me. And this is a great quality of life addition. Also, one thing that always bugged me, control flow narrowing for constant index access. I have here a record of string and unknown, and I access the record with a key and ask if the type is string. And the next line, TypeScript says, oh wait, I don't know if this is a string or not. Then you would have to extract the value into a variable, do the check on the variable, and finally TypeScript control flow analysis gets what I want. In TypeScript 5.5, TypeScript understands that case, and this error is gone. This is cool. Who in here thinks regular expressions should not be in your code? Cool. And who does it anyway? Yeah, all right. That's what I expected. Regular expressions are amazing. They are worrisome, and they have been glanced over in TypeScript up until now. So TypeScript just ran over a regular expression and said, okay, here it starts, here it ends, be done with it. Now, TypeScript tells me that at this particular point here, I had an unexpected parenthesis, and did I mean to escape it with a backslash? Oh, this is actually quite nice. In the next line, TypeScript tells me that the back reference refers to a group that doesn't exist because there are only 2 capturing groups in my regular expression. Maybe I should use one of those. This is honestly, this is incredible. And last but not least, here I'm having a named capturing group that does not exist in this regular expression. This is a particularly new feature of regular expressions that comes with EcmaScript 2018. How do I know that? Because if I have a different compile target, TypeScript tells me that this feature is not available in my compile target. And honestly, this is not only quality of life, this is freaking awesome. And so helpful. So I have a couple of regular expressions, we all do. And knowing more about it when I write and not when I need to pick up some documentation on regex 101 is actually quite nice. This is also quite interesting. Disallowed nullity and truthy checks. Here is a regular expression that always returns true because I didn't test anything on it. It just checks if the regular expression is there. This is potentially not what you intended. Next line, who spotted it? This is an error function and not greater equal. So this is also potentially not what you intended. And down there, I have value less than options max, and then I have nullish coalescing with 100. So the idea is that if value is less than options max, what is the idea? No, the value needs to be less than options max or 100. That's what I wanted to say. The reality is this is a false precedence. This is how it really is. It checks a Boolean against 100. This is also potentially not what you intended. Those are all cases that TypeScript couldn't catch up until version 5.6. And those are things that are just overlooked. So I'm very, very happy that those things exist. Checks whenever initialized variables. That's also one thing that TypeScript always could do. So I have here result of number, and I do something, and it's potentially not initialized, and TypeScript tells me at this line, hey, wait a second, it's used before it's being assigned. So it checks in all my branches that result should be assigned. So this is great. This is great that it does that, but it always did that. It didn't do it when I wrapped the console log in a function that is inside a function. That's also something that could happen. TypeScript was very optimistic and said, well, I'm pretty sure it will be initialized somewhere, and looked over this case. Today, TypeScript also checks those cases. Again, lots of new correctness features, lots of things that can happen because your code is designed in a very certain way. Again, more quality of life. Now for my most favorite feature, narrow conditional index access return types. It's coming in TypeScript 5.8. 5.8 is not being released. It comes out early next year. It's a feature by Gabriela Brito, who has started working on the TypeScript compiler, I guess, a year ago. This is the pull request. It's a beautiful pull request. The text on it is pages long, detailing every nook and cranny of that feature. But what does it do? So I have been a proponent of conditional types for a very, very long time. I have here a label type T, and if the input type extends string, I create an object of this shape. If it extends number, I create an object of this shape. Otherwise, I don't create an object. I call it never. This is what the conditional type does. And here I use it in a function as a return type, in a return position. So I say if I create label, the input is either string or number, so the output then should be either label of T or ID of T with label of string. That's the idea behind that code. And the function signature works really, really well. So this is something when conditional types came out, this was brilliant, and there were lots of JavaScript code that had kind of branches or conditions like that. So good, everything fine. The moment I started adding an actual implementation that does what the type signature tells me to do, things get a little hairy. So here I ask if the input is of type string, then I create label of input. In the other branch, I know that input is number, I create the other object. So if you pass that control flow, you understand what's going on there. The problem is TypeScript didn't. TypeScript told me that this type is not assignable to label of T, but it is. You can see that, I can see that, but TypeScript can't. And there's lots of reason for that, mostly because the moment that you have a generic type parameter somewhere that extends from a union, TypeScript narrows it down to T and string or T and number. For particular use cases when you annotate your type instead of inferring it. All right, so this is cumbersome. There are a couple of ways to work around it. One of those ways is to add function overloads, but if you have been here last year, functions overload are just shifting the problem to something else. Or you have as type calls, which are also just cheating around what the type system should be able to do. And I'm very happy to say that with TypeScript 5.8, which comes out next year, those features work. This code now works. Control flow mapping to conditional types and index access types in return positions. This is amazing. It bugged me so much that I wasn't able to write code like that. And I have 2 chapters in my 2 TypeScript books just on that particular topic. But now the question is, and this is interesting, what did it cost? Not you, because you get that stuff for free, but what did it cost the TypeScript team? That's easy to answer because we have the pull request. First of all, Gabriela deleted 42 lines of code. That's nice, that's good. Gabriela added 11,876 lines of code. What was the effort? The work was done from January 3 to October 30. 10 months of work. While working on a moving target, because TypeScript didn't sleep, they didn't pause working on it. They basically checked the entire control flow analysis logic for generics to be able to finally understand my stupid label example. Think back when you worked for the last time for 10 months on a single feature. What was the impact of that feature? I'm pretty sure it was tremendous, otherwise you wouldn't have worked 10 months on it. And honestly, this is amazing. This is not only some work to fix a bug. This will open up more opportunities for TypeScript to get even better. So thank you, Gabriela. This is amazing. I'm really looking forward to that release. Time for another perspective change. So initially, I complained that TypeScript is missing features for stuff that I would like to do. But then we saw that TypeScript actually continually gets better and better and better, and releases like 5.5 and 5.8 can be considered blockbuster releases. They're adding quality of life features that are potentially even more important for you than adding new features to the type system. And those essential features, like conditional types in return positions, they take time. It's not easy to just fix a bug or add a new feature, especially if you design a type system that should work for decades. But I also think it's true that we peaked with the type system. I think we already reached a level where we potentially can't even add more things. So why not make the best out of it? And knowing that, maybe I should rethink my code. Now it gets philosophical. You remember the mutability problem that when I can assert that the type has the visited property, but then it's getting lost again, and the question is this even correct? Is this how I should model my application? I did it in JavaScript all the time, but maybe when writing TypeScript, I just create a set visited, which is a set of person, and every person that I visit, I put a reference into that set. And it makes it even nicer, because now I can just access all visited person every time. That's my builder example, you know, the one thing where I couldn't have both. I could either have interior mutability or a fluent interface. Well, it was a very complex type. Still amazing that it took me 5 lines of code to basically model that behavior. So it's amazing that TypeScript allows me to do those things. But maybe the type should be a little bit simpler than that. What if I just accept strings? And if I call .opt, I'm not getting an object with key value pairs, but a map with string keys and Boolean or string values. And this adds a little bit the semantics of the whole thing. Now, I don't need to trust that the object will be good the moment I add all my elements. Now I get a map where I, as a developer, can check if the option has been parsed, because otherwise I can't access the property. So actually, the types became easier, and my code became a little bit safer, because now I need to do additional runtime checks if everything works out. So honestly, I think this might be even a better solution. Yeah, I gave you a warning. This is a very personal talk. My NGPE TypeScript trilogy, and I don't know how much you are into trilogies, but usually the third part is where you overcome all your fears and obstacles and become a better person at the end of the day. If you know what this image refers to, please come talk to me after my talk, because if you have the right answer, you get one of my books. The first 3 people who know it can get a prize. But yeah, the third part should make us better developers. And I think if we understand that TypeScript will get better, and we get more correct features, not just type system features, I think we also can write better programs. This mirrors my own TypeScript trilogy that I have. I wrote about the powers of TypeScript in 50 lessons. I wrote about real-world type-level programming, you know, where stuff gets wrong or gets bad, in the TypeScript cookbook. And I'm actually writing on a third book where I think what needs to happen beyond TypeScript. And I also hope that this is my trilogy where I was able to change your perspective and broaden your horizons. I hope to change your perspective on what the type system can achieve in my first talk. I hope to change your perspective on what the type system can't achieve in my second talk. And now I want to change your perspective on the completeness of TypeScript's feature set. Because this one question is still open. How complete is TypeScript? And this is quite a conundrum, because we have seen that there are situations TypeScript can't express. TypeScript is one of the fastest growing languages on GitHub in 2024. There are still more JavaScript repos coming, but TypeScript is catching up really fast. And in the State of JS survey in 2023, which is not representative, but other surveys come to similar statistics, it states that almost 91% of all participants use TypeScript to at least some degree. And this is a critical mass, and this makes the whole discussion about completeness very interesting, because with more projects and libraries being written in TypeScript, more people use what TypeScript has to offer, or what TypeScript can offer already. And in turn, TypeScript doesn't need to hunt after JavaScript features that won't be used anyways. So TypeScript can allow itself to work on quality of life because it is first and foremost a stable programming language. And if you ask the question if TypeScript is complete or incomplete, I think the answer is yes. Thank you very much.